Hi there, have you ever heard the word algebra or have you ever been familiar with Cartesian coordinate plane? Well, if you're not familiar with both of these, they both use x and y. Now in this video, we are going to make more use of letters rather than just numbers in a mathematical problem. Let's start. Back then in our elementary days, we've been used to counting numbers and then we add, subtract, multiply, and divide with them, right? But in high school, we make use of letters rather than just numbers in a mathematical problem. Well, those letters are actually called variables in a mathematical discipline called algebra. Well, how did algebra actually begin? It began during the time of Muhammad bin Musa al-Khwarizmi, who is an Arabian, and he lived within 750 to 850 Anno Domini. He wrote this book entitled The Compendious Book on Calculation by Completion and Balancing, and there he described algebra as a mathematical discipline that is independent of geometry and arithmetic. Well, what does this mean? This means that even without arithmetic, even without geometry, algebra is a separate subject and can be tackled alone. Well, in algebra, when we have letters, they are also combined. They're also being combined with numbers, and so they're called terms. Now, this is a term right here. In a term, we have the coefficient, which is always the number. We have the variable, which is the letters. They cannot be just only x and y, but even a, b, c, and all the letters in the alphabet. And then we have the power or the exponent, which we also call the index. If I have x, y, and z, and they're just one term, and they have also powers in the top, or in the top right part, they are not called indexes, but they're called indices. Well, now that you have learned about the different basic key terminologies in algebra, and even history of algebra, let us now begin to learn about the different basic mathematical problems regarding algebra. Now we have here a set of terms on the board. Now all we have to do is just to find all the like terms in the set. Now when we say like terms, these are the terms that are very similar to each other in terms of the variable and with exponent or index. Now, in this set we can find many like terms. All we have to do is just to find them. Now we start with 2x. Now help me find the terms that are similar to this term. Now is 4 similar to 2x? No, because it doesn't have a variable. How about 5x squared? Not also, because it is being raised to 2. And even 4y and 6y, since they have their variable is y and not x. But in the second row, I can find two terms that are similar to 2x, and that is 5x and 7x. How about for 14 over 5x squared, which is on the third row here? Are there any terms that are similar to this term? Yes. We can find 2/3 x squared and 5x squared. Even though this is a fraction, since it's just a coefficient, there is no problem with it, since all we have to search and observe is its variable and its exponent. Perhaps those are the things that are very important when you're searching for the like terms. And we have here 37, wherein its similar term is 4. Perhaps you can combine 37 and 4 in all operations, mathematical operations, I mean. So we have here 4y, and the term that's similar to 4y is the one beside it, that is 6y. And then we have here 49a and 27a. And for the last three, since there are no any other terms that are similar to it, all we have to do is just to box them. Perhaps when we mean like terms in this set, we mean that we can combine all of the terms that we underline in operations or mathematical operations such as addition, subtraction, multiplication, and division. But unlike terms can only be combined in multiplication and division. For example, I'm going to combine 14x cubed and 8a squared. Can I combine them with addition? No, because of what I said. For 9y squared and 49a, the same is the case. So right now I have here the first 5 mathematical problems that I've shown to you a while ago. So, as you can see, for every mathematical problem, I have prepared representations for them. Well, these representations are called algebra discs. Again, an algebra discs are like a coin. They have both a head and a tail. The head is the positive side of the algebra disc, and the tail is the negative side of the algebra disc. Well, algebra discs are actually tools that you can use either mentally or for written. They are used for you not to get confused with negative numbers. Well, you can even use algebra discs for a problem that has purely positive numbers, just like the first problem we have here. 2x plus 5x. So all we have to do is just to represent or put algebra discs that would represent the problem. So we would put 1x or 2x to represent 2x, and we would line up 5 of 1x to represent 5x. So since we do not have anything to cancel, when I say cancel, that means a pair of a positive and a negative algebra disc, and it's not present in the problem, we have nothing to cancel. So all we have to do is just to count all the algebra discs we wrote here. So that is 1, 2, 3, 4, 5, 6, 7. So that is 7. So 7x will be our answer for 2x plus 5x. The second problem, we have 8x minus 16x. So we would use algebra disc 8x and 2 negative 8x for negative 16x. So we would cancel a pair of a positive and a negative algebra disc because 8 minus 8 is equal to 0, so they don't have value. And we would have negative 8x, which is left. And that would be our answer for this problem. For the third problem, we have 4 multiplied by the quantity of 3x, or simply 4 times 3x. So this will be the representation of this problem when you use algebra disc. And we have this, and this means 4 groups of 3x if we're going to use algebra disc. And so if you can see, we have triangles here, and the triangles would mean distributive property, like what I said in the last video. And so we would put 3 discs here for every group inside the rectangle and beside the triangle, and we would combine them in the end. So all we have to do is just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our answer for this problem will be 12x. For letter D, we have 14x plus 15y. If you can see, they are unlike terms. Well, in the table a while ago, unlike terms can never be combined in a problem that involves addition and subtraction. So what can we do here? If you would use algebra disc, you would see that the very good explanation for it. If you would see, there is nothing to count more, but just 14x and 15y. Since both of them are unlike terms, we leave 14x and 15y as our answer. How about 24y divided by 8y? This is representation using algebra disc, and we would see that I put 1, 2, 3, 4, 5, 6 of 4 y's, and I group them into 3. So I would count 1, 2, 3, that is 3 groups of 4 y's. So what would be our answer for this problem? It's just 3, not 3y, because later as we go on with more videos, I would explain to you the laws of exponents, and there you can find the true reason why it's just 3. Well, you can even check your answer for, right now. 8y times 3, which is our answer, and it will appear 24y. We cannot say 3y because 8y multiplied by 3y, if we're going to check, will be 24y squared. So before we have another set of math problems regarding algebra, let us first tackle about this set of rules and reminders that we guys have to follow before answering such math problems. So there are certain rules and reminders for addition, subtraction, multiplication, and division. Always remember these. For addition, all you have to do is just to follow the sign of the highest number for your answer. Now I have certain examples right here. Negative 7x plus 5x is equal to negative 2x. Well, if you are going to do this problem in algebra disc, you are going to represent 7 discs that are all negative and 5 positive discs. And you're going to see that you are able to cancel 5 positive discs and negative discs together, and what's are left are negative discs. You will count the discs and they are 2. And so our answer will be this one, negative 2x. It's easier to explain in algebra disk, but here if we don't want to use algebra disk, this is what we're going to follow. We're going to follow the sign of the highest number for us to have the correct answer, negative 2. Because it's not the same like 7x minus 5x, which will give us an answer of a positive 2x. But since we have a negative number, right here, we have a negative sign right here, so all we have to do is just to look where is the highest, or which is the highest number among these two numbers. And once you found it, follow the sign. If the highest number is positive, then your answer must have no negative sign. But if the highest number is negative, then your answer must have a negative sign. For the second problem, we have 5x plus negative 7x. The negative 7x is in the parentheses. So you guys must not get confused, because this problem will just turn your problem into subtraction. But since we put the addition sign right here, it is a part of confusion, but you guys must not get tricked by these problems. So this just means you have to distribute the sign right here, or just removing the addition sign and then place the negative sign in the middle. Now you have 5x minus 7x is equal to negative 2x. It's just the same as the problem right here in the first. All you have to do is just to reverse the problem if you want to not get confused. It will give us the same answer just like this one. And the third problem, negative 5x plus negative 7x. This time, two numbers have negative signs. And so all you have to do is just to think about these two numbers as they're both positive. And then you're going to add them. So we have 5 plus 7, and that is 12. And then you're going to insert the negative sign right after. For subtraction, things you have to do here will just vary. For example, this first problem, you have negative 7x minus 5x, which is actually the same thing right here in this problem. Now all we have to do here is just to add them like you think they are both positive. 7 plus 5, and that will give us an answer of 12. Then you just insert the negative sign after to make us not get confused. But always remember that you have to insert the negative sign for us not to get the wrong answer. For the second problem, we have 5x minus 7x. That will give us an answer of negative 2x. Perhaps I just reverse the problem, going to make an addition. But then if, for this problem, imagine that 7 is positive, and you're going to subtract it with 5. So that is 7 minus 5, and that is 2. Then insert the negative sign after, since the highest number here is a negative number. Now, for the third problem, we have 5x minus the quantity of negative 7x, or 5x minus negative 7x. It will give us an answer of 12x, since I have to distribute this negative sign right here inside negative 7x. And so, since a rule here in multiplication says that negative multiplied by negative is equal to positive, so this sign will become positive. So that's 5x plus 7x, and will give us an answer of 12x. Now for multiplication, multiplication sign can be expressed in a normal multiplication sign, which is an x, or a dot. So if you're going to higher grade levels, the multiplication sign will become a dot, and so we have to become used with a dot there. Since in algebra, since you have x and y, and it will mostly be tackled in mid-high school, the x will actually be the same as the multiplication sign, so many people will become confused. That is why many teachers, or many of us, should just use a dot to refer to a multiplication sign. Now we have a set of rules here that are very, very important for us to remember. That is, positive multiplied by positive is equal to positive, or a positive number multiplied by a positive number will give you an answer of positive number. Positive integer multiplied by a negative integer will give us an answer of negative integer. Negative integer multiplied by positive integer is equal to negative integer, or negative multiplied by negative is equal to positive integer. Why is this rule right here says that negative multiplied by negative is equal to positive? That is because of the algebra disk explanation. which is actually easier for me to explain, and that is here. So you have here a box with an algebra disk inside, and then we have a triangle that would refer to distributive property, which also has a negative sign inside. Since distributive property in algebra disk means to flip, we're going to flip this algebra disk to its positive side, which is the head side of the algebra disk. Now that's how easy it is to explain it in algebra disk. How about in division? In division, we also have same rules that we have to follow. Yet, in division, its sign can be either the normal division sign, which has two dots and a fraction bar, and a slash. Well, they're just the same, they refer division. We have a set of rules here which are the same, it's just that the difference is that it is division sign. Same explanation, we have negative 4x divided by negative 2x. Wherein the answer is 2, that is because I line here negative 4 negative x algebra disk that would represent negative 4x, and then I group them into 2 with the negative sign inside the triangle that would refer to distributive property. And then I flip them, and then I count the groups as 1, 2, and it will give us an answer of 2. I have to cancel the x since a law of exponent that would say an invisible one on top, you have to subtract them. And since the answer of that will give you an answer of 0, and it will have no value, so you have to cancel them. And the answer will be 2.
Watch the second part of this episode in a video entitled Fundamental Algebra in Algebra Disk Part 2. Thanks for watching.